day, I want the model to talk the language of a pathologist. When I look at an image, there are few features that I look at, and some features are more important, some features are less important. And then it all comes together and finally makes a decision. So I need an AI model that not only gives me what that classification is, but actually tells me that, okay, I looked at this feature, I looked at that feature, and then I put it all together. And I'm also going to tell you as to how important was this feature to me versus that feature.
Hey, you found Ways We Learn, an investigation of how learning happens across all ages and modalities. Let's go learn something. Hi, and welcome back to Ways We Learn. I'm Sean, and I'm here with Joe. And there is a lot of buzz these days about AI, and in particular, generative AI, like ChatGPT or Gemini. And we've talked about Gen AI in several of our episodes. I'm sure we're going to cover it again, but that's just one facet of the artificial intelligence field. There's AI in self-driving cars. There's AI in your smartphone. Maybe you have AI in your refrigerator. And there's AI that's helping to advance the field of medicine. And that's what we're going to be talking about today. Some of the ways AI is advancing healthcare, from diagnosing diseases to designing personalized treatments to even uncovering new medicines and ways of saving lives. Joining us is Dr. Akash Parvatikar, an AI scientist and product manager for the PathologyMap platform at HistoWiz, a company that's accelerating scientific research and discoveries through the automation of histology and digital pathology solutions. Akash graduated with a PhD in computational biology from the joint Carnegie Mellon and University of Pittsburgh School of Medicine, specializing in explainable AI for early breast cancer diagnosis. His interests incline towards application of AI in digital pathology, and he's an advocate of explainable AI in healthcare. And Akash is passionate to create awareness in the adoption of AI in healthcare and has spoken at numerous events and conferences. And I'm not sure I fully understood everything I just said to you, but I know that Akash will be able to explain it. So Akash, welcome to Ways We Learn.
Thank you so much, Sean. Thank you, Joe, for having me here. Equally excited to be on the podcast and discussing some very new and interesting things about AI in healthcare.
Excellent. Yeah, we're really glad to have you. So let's just start with your background and how you got into this field in the first place, and then we'll move into more of what you're doing now.
Absolutely. So I was personally motivated to be in this field because somebody in my family was wrongly diagnosed with lung cancer.
Oh, wow.
So I always had this notion that even though we went to the best of the best hospitals and treatments, why was it that the patient was not diagnosed the way he was supposed to be? And this stuck with me for years to come. And so I came here to the US to do my master's in information science. And I was also researching in the computational biology department. And there was an opportunity that opened up in a lab, Dr. Chakra's lab, where he was essentially working on developing AI for breast cancer diagnosis. And it so happens that even breast cancer has a very high rates of discordance among the pathologists. So it was more like a quick match for me because I was always intrigued as to what is the underlying complexity for the right diagnosis of cancer. A, from the cancer biology perspective, but B, the AI perspective and how these two could come together to sort of like join hands and create an impact.
And when was this that you became involved in the AI and breast cancer examination?
This was 2018.
2018, so 6-ish years ago, way before
Absolutely.
many people had even heard of the notion of AI in medicine. Yeah.
So this was
Yes.
more in the world of machine learning and part of that side of AI, like that kind of, I guess, sub-brand of AI. Is that right?
I would call my PhD work as an intersection of pathology, AI, and more of cognitive psychology. So I tried to understand the data from a pathologist perspective and their involvement with making decisions on a daily basis and what really goes on in making those decisions. How like what is bias? What are those associations that they have to undergo like cognitively to make a decision? So I like this was more towards like building not a deep learning, not the black box deep learning, but more sort of like an explainable machine learning framework for detecting breast cancer.
When you say, and I said that in your bio, the explainable AI notion, can you define that? You just said it again, explainable. What does that mean exactly?
I want something which does not just give me a classification outcome, but I also want to see how it arrived at this. Even the mechanisms that you follow in trying to lay out how this all happened, it could be some complicated like mathematics that goes behind it and algorithms and all that. But at the end of the day, I want the model to talk the language of a pathologist. So what I mean by that is like when I look at an image, there are few features that I look at, and some features are more important, some features are less important. And then it all comes together and finally makes a decision. So I need an AI model that not only gives me what that classification is, but actually tells me that, okay, I looked at this feature, I looked at that feature, and then I put it all together. And I'm also going to tell you as to how important was this feature to me versus that feature. Now, if it resonates with years and years of pathology practice, then we have an explainable model.
I see.
So, yeah.
That makes perfect sense. Yeah, I actually just yesterday had a doctor appointment with someone who it was incredible to me just watching how her mind worked and making the connections between things that she was reading in my blood work or whatever and saying, okay, because of this and this and this together, we're not going to do this, but because this is there, we're going to try. And so you're talking about that, but through AI, where you actually
Absolutely.
understand where it's coming out with it, as opposed to, like you said, the black box model, where
Exactly.
it might be coming up with an amazing solution, like we see
Yeah.
in Gen AI. You have
Yeah.
no idea how it got there. So I think
Exactly.
that's, yeah, okay. Thank you for
Exactly. And,
explaining that.
and also like what features you see should also be explainable. Like as you just told, right? Like the physician whom you consulted, she gave this sort of an explanation that she's looking at this, and this, and that is why she came up with whatever report she wanted to
Right.
generate. And even that should resonate with the medical practice. When we talk about explainable AI model, if the explanations are not in the language of a pathologist, even then it's very hard to understand. Okay, you're giving me explanations, but I still do not understand like what these explanations are. To give you like a very general example, like when you look at a kitchen, you instantly tell that it's a kitchen. Why? Because you're looking at a refrigerator, a gas stove, a kitchen island, and cutlery and all that, right? It's not just that, but they have a certain form of a spatial orientation. Like you have the gas stove and then you have a microwave which is like right above that, and very close to it you have a refrigerator. So all of this you're processing in quickly telling it's a kitchen, so there is no confusion over there. But when you start removing objects from that, like say you remove the gas stove, you remove a microwave, you reduce the size of the refrigerator, then your confusion starts building. Now would you really call it a kitchen, or would you call it, I don't know, maybe an office which also has a refrigerator? So, you bring it all together to make a decision, and this is precisely what happens even in pathology. So,
Wow.
yeah.
Sorry,
Just
go
to
ahead.
make sure that everybody's on the same page, pathology is the diagnosing of a disease, right? Trying to figure out the cause and potentially the procedure, the cure, right?
A procedure and the treatment.
And the treatment, I
Yes.
mean. I just want to make sure people knew that.
What actually, and this is I'm not a doctor. What actually is the doctor interacting with, and then what is the AI giving them? Is it a image, whatever, an image of an MRI, whatever, a medical image of some sort of something, and that's then been highlighted by the AI? Or is it like, what actually is the interface that a doctor or pathologist is experiencing the work?
Okay. I think it will be really helpful for me to like, share some images with you here at this point, which will just help us to build a common baseline, and then we can open up discussions on this aspect or medicine in general.
That sounds great.
So I could go ahead and share my screen here.
Yeah, go for it. When I met with Akash, just as he's getting this set up, we talked about just how difficult it might be to understand some of this stuff. And so I said, hey, could you come in and actually show us some of what you're
Very
working
cool.
on? And so this is a first for Ways We Learn here. We're doing a screen share. And if you are not listening, if you are listening but not watching our video version, I invite you to find our video version, which I will make sure we link in the episode notes so that you can actually see what he's sharing right now.
Cool. Well, thank you, Sean. So, well, the traditional anatomic pathology diagnosis is still considered as the gold standard among the clinicians. But so usually the workflow is like a physician takes the biopsy in a clinic and sends it to the pathology lab where the biopsy is processed, which involves certain steps, and then the tissue gets onto a glass slide, which is then sent to the pathologist for diagnosis, and that happens under the microscope. Well, so this particular practice is quite inefficient, error prone, and highly subjective. There is indeed a very high degree of disagreement between the pathologist when they try to diagnose the pre invasive breast cancer. The features are quite amorphous, they are not clear, and there are no clear guidelines as to how much of a feature needs to be present for it to be diagnosed for a certain category. There is quite a high degree of disagreement between two labs, between two hospitals, or even within the same lab. So, because of these limitations, it has opened up many possible requirements wherein AI could come in. So, I think one of the major requirement of AI is trying to understand like what features are already being modeled, and this is easily available in your pathology books where there are clear guidelines as to what features we need to observe, and then come up with like eye tracking experiments wherein you actually see what features they are paying attention to, how much are they paying attention to each of these features, and try to come up with a model that tries to sort of like mimic this particular cognitive behavior of the pathologist. So this field that I'm talking about is called as the digital pathology, and it has revolutionized how we think about pathology diagnosis, and it has motivated researchers to build AI models. However, to build these AI models and have a clinical adoption into the hospitals, it needs to be explainable. And by explainability, I mean it needs to satisfy two criteria. The first one being it should be clinically interpretable, and second one, it must improve the workflow efficiency. So you cannot have an AI model in the hospital wherein the end user is not sure how it came to this conclusion, because at the end of the day you are dealing with patients' lives over here, and you cannot let the AI machine run through the entire set of decision making. But of course you could use this as a tool to help you in your workflow efficiency. But if you have an AI which does a classification, it needs to be explainable. So this is the work that I did during my PhD. Of course, it was research only. But then at HistoWiz, really our mission is to again accelerate scientific research and discoveries by automating histology and digital pathology solutions, but also including okay, how explainable are these AI models and how much transparency can I offer to our end users.
And just assume that I might not know what histology is. What is histology?
Sure. So his histology is the process of taking a tissue from the organ and process it and embed it on a glass slide, and you precisely look at the glass slide under the microscope to see if there are any diseases or some things like that.
So that's the examination part, and then the pathology is the
The
putting it all
diagnosis
together and
part of
understand
things.
the diagnosis. Yeah, got it.
Exactly.
And so what HistoWiz is working on is trying to pull those things into or to build out those things in the field of AI to sort of replicate what's possible with a skilled clinician, but through, like you said, an explainable model that is not going to just say this is a diagnosis without explaining why.
Absolutely. So HistoWiz is mostly working on the preclinical side of things and not the clinical side of things. And essentially what we do is we digitize the tissue slides, and we have few AI models for checking qualities and few other features that are being used by our clients. And the work that I explained regarding breast cancer was my PhD work, where I spent years together to develop an explainable framework to detect pre-invasive breast cancer.
Wow. So, Joe, I think in answer to your question, yeah, they are using the actual
Yeah.
images, right? That's what you're putting in. It's a digitized version
Absolutely.
of what someone would look through a microscope
And
at.
then the person, the doctor, what do they get back? Do they get a written report? Do they get an image, with with additional details overlaid on top? Like, what actually is the interface?
Yeah. So they could see the entire like whole slide image of the tissues.
Uh-huh.
So up until recently, they were looking at these under the microscope, but
Okay.
now you are digitizing this and putting it on a big screen, so they
Got it.
can see the image as is, and they can pan, zoom, and all that what they were already doing using microscope. But digitization also enables AI tools to come into play, and they could depending on the availability and feasibility, they could like select what tools they want to look at, and it will be an essentially an overlay on the
Right.
images, and it could be like a guiding tool for you to help diagnose. And I would like to give a context to our audience. You are looking at one image which is approximately anywhere between 400 megabytes to several gigabytes, and you're
Whoa.
talking about an image
Wow.
which has like a million pixel of just one tissue biopsy. So it's a huge image. It is not like a
Oh, wow.
1K by 1K images of like of the scenes or like
Mhm.
real images that you have. You're looking at like almost a million pixels in one image, which
Of
the
a very
pathologist is
small
trying to
area, right?
of of, of a really small biopsy that they would have
Huh.
taken
Wow.
of a tissue slide. So
Interesting.
yeah, and I think so there is a huge context to cover when they look at this entire image. So having tools will enable them to focus on the slides, focus on those regions where like is most important, because they might and they will and they do miss out on few areas, and that is also one of the contributing factors for
Yeah.
misdiagnosis.
Is it so large because either you or the doctors are kind of zooming in and out to be able to get more detail on specific things? I guess why besides more is more,
Yeah.
why the
Yeah.
need to
Yeah.
get such a high resolution image?
Absolutely. So you need to, in order to see some features, you need to go at 40x resolution.
Got it. Okay.
You cannot see, yeah, and that is why the size of the image is huge.
Right.
And to like, and 40x is the standard
Mhm.
in almost all labs in US for diagnosis, and that translates to a very huge file size.
Got it. Got it. Got it.
Yeah, because you're sort of presupposing the need to zoom into any part of that image, so it's got to be
Exactly.
massive resolution.
So
Exactly. And even when you zoom in, you would want to see those cells and what's happening around the cells
Right.
as precisely as you would see under the microscope.
You mentioned in the development of this that there was an attempt almost to mimic the way a pathologist reads the data or reads the image. That you said they're doing eye tracking and scanning and trying to sort of replicate that. You're saying that you're actually building that process into the way the AI analyzes the image. I guess my question is, why is that the right way to go? If what I said is correct, why is that the right way to go as opposed to potentially using the abstraction of doing this through a computer, through an AI, to find some other method that doesn't rely on a single set of eyes looking at a single thing at a time?
Oh, well, yeah. So I think to answer your first question, so this framework sort of mimicked what a pathologist would usually do, which
Mhm.
is looking at a set number of features. So Sean, like these features are well cataloged in books such as like World Health Organization classification of tumors. So this is like a guidebook throughout the world to detect cancer. And just for breast cancer, there are close to 10 to 12 volumes. and each volume has like 15 chapters, which speaks about like every category of breast cancer out there.
Oh my
So
gosh.
here we are looking at multiple categories. So during my PhD work, I focused on 2 chapters of one volume to talk about the pre-invasive breast cancer. And in that, there were close to like 20 features which the pathologist pay attention to. And this has been like well studied and documented. So my approach was to first identify those features which is already sorted and validated in the medical literature. And then my framework essentially wanted to learn as to how these features come together towards a diagnosis.
Mm.
So it was more like, okay, you give me an image. First, I will detect all these features. Then I will have a machine learning framework which basically learns from the training data and tries to learn these importance scores. So say at the end of this framework, it said, okay, feature number 1 and 2 have a importance score of zero point 0.9 and feature 3 and 4 have a low importance score of zero point 0.1. Then I had to take it back to the pathologist and ask them, is this what you have studied? Is this resonating with your practice? If they say no, then the algorithm is misleading. I need to go back and fix the algorithm. But if they have a consensus that indeed it is what they expected it to be, then we have a framework which is explainable. So now you give me an image, I will detect the exact same features what you might typically pay attention to, but I am also giving almost the same weight as you might have given when you are looking at those images.
So I guess my question then is why, given what you said about the sort of varying degrees of, I don't want to say accuracy, but that one pathologist might say this is potentially cancerous, where another would say the same features are not. Why try to mimic that approach that could lead to either subjectivity or missing it or whatever the reason is that they would see it differently? Why not try to develop other approaches? Is it just purely because that is what the scientific evidence shows? The history of breast cancer research
Yeah.
shows that that's how we identify it, and therefore you're trying to sort of not speed up, but make it more efficient to diagnose? Or is it that there is no better way to do this, and we just need to do more of
Oh,
it?
no, so I think that that's a very good question, and we thought about it like days together, weeks together before thinking about this framework. First thing is digitization of tissue itself is an emergent field. Only in 2017, the US FDA approved using whole slide scanners for primary diagnosis.
Oh,
So
interesting.
even
Wow.
up until then, it was all microscopes. So this particular digitization initiative is still an emerging field in US and outside. So our first goal was to, like, if a clinician had to adopt AI, will they agree to adopt a machine or a system which is entirely different, which looks at whole new features by Gen AI or something, or would they rather adopt something which they are more comfortable with? So it's more like a hand holding to reach a stage and make like good quick wins.
And there's the psychology part of your degree.
Yeah.
Yeah.
Exactly. The effort when I started my PhD was essentially how much can I be as close to a pathologist's decision making as possible. Now we can create experiments wherein we could remove some features and run the diagnosis experiment and maybe put in some features. Again, it comes to like the kitchen problem, right? So you remove the gas stove, you remove the microwave, you just keep in the refrigerator, you might still call it a kitchen. But then my friend comes in and he sees a printer in the corner and he says, this cannot be a kitchen at all. I think it's an office room. I saw a printer right there, and that completely changed my decision. So there comes a point wherein you and I will not agree. And I will give my own justification, which is not like false, and you might give your own justification based on
Yeah.
how you were trained and all of that. So this is what happens even in cancer. Cancer is not like, okay, you have this, then it's category A. You have that, it's category B. No, it is the case for some types of cancer when the cancer has metastasized and it's invasive. But for most parts of the cancer which has not yet metastasized, it's in pre-invasive, it's a game of its own.
Yeah,
And
of course.
why it's important to diagnose is because there are different treatment options even within the pre-invasive.
Well, and also diagnosing it earlier would be a massive advantage, and that's I'm
Absolutely.
curious whether that's where you see this going. Is that the whole point here? That as you start to, I love the kitchen analogy. I've actually had that
Yeah, it's good.
experience of when I was looking for a house, of walking into a house where there was no stove, there was no refrigerator, and we walked into this room, and I went, I think that's a kitchen. I'm not
Yeah.
really sure. So it definitely, I know what you mean. But with breast cancer diagnosis, the earlier you can spot it, the more treatable it becomes. Therefore, identifying those just all the different possible configurations that might end up becoming cancer would
Exactly.
allow you potentially to step earlier into that diagnosis timeline and say, okay, this is much more likely to be cancer, even though it doesn't have these other factors. Is that
Absolutely.
sort of the whole point of this, that you then take the
Absolutely.
subjectivity out of it? You
Exactly.
say this is much more probabilistic that it's going to go that way.
Exactly.
Speaking of kind of psychology and cognitive psychology, have you, as you sort of bring this into the real world of doctors reading it and all that, and inevitably there'll be a moment where the AI disagrees with the doctor. How's reception been? How what's worked, what hasn't worked? Yeah, how's reception been?
Yeah, so I did few experiments during my PhD when the pathologist did not agree with the AI,
Uh-huh.
most of the times actually,
Yep.
like not once or twice. So that is when it gave me the scope for seeing like, okay, what's going wrong? Am I missing on few features? Do I need to tweak the parameter set as to what I'm looking at, or do I need to have an entirely different framework? So I think these are the questions you ask from like a computer scientist mindset, and it's more about like you try, you fail, you try, you fail, and
Yeah, of course. And so does that when you were doing your research for the PhD, was that something you were considering? Was it's not just about being right, but about convincing people you're right?
Oh yeah, absolutely. It's about being right and convincing people that this will work. But not just that. I think one thing that I spent way more time than proving myself right is knowing when will I fail.
Hmm.
I think that's extremely important to build any AI model, not just in healthcare, but anywhere else. Understanding the failure modes. When will the AI not work? I spent a lot of time in trying to throw images at my framework where it might fail. And well, you could do only little with the time that you have and the scope to work on it. But I think making it open gives a scope to improve,
Yeah.
because if you develop a model and you do not know where it fails, then it's very hard to make innovation in that direction. So I think yes, I did spend a lot of time in convincing, but like, if you're, I'm more than happy to share my research papers, and the research
Right,
papers
of
also
course.
talk about what are the limitations and where does the model exactly fail and does not work.
And so I'm just so curious about this. So are you talking about the same kind of training, or a similar kind of training that would go into a large language model or machine learning model where you've got, you know, thousands, hundreds of thousands of images, or is this a more sort of specific guided training, or how does training this model even work?
Yeah, this is still a supervised training where you have a label for every image and you just work with that. So then I just have a training set with say like 1,000 images and they have 1,000 labels, right? We had a team of 3 pathologists from
Cool.
McGee Women's Hospital to do the diagnosis, and even there we took consensus diagnosis. What I mean by that is, even among those like 1,000 images there might be discordance, but we took like majority.
These are the
So
ones they're pretty sure is the
uh,
same thing. Yeah.
exactly, exactly. So these are like top breast subspecialists in United States. So we took their labeled data, and then we ran the framework that I had. Of course, in the background, it detected features and computed like scores and all of that. But what I also had was something called as a prototype set. So a prototype set is basically, it had all the different variations of every single category. Again, to make it simple, so if it was like kitchen versus living room, I had almost all variations how a kitchen would look like, and what an expert would call a certain room as a kitchen. Like, you can have a kitchen which just has a gas stove and nothing else. You could have a kitchen which has like everything, full amenities and all that. So this was your prototype set, which I formed for every single category. And then every training image that I received, I compared it to the prototype set and asked this question as to how similar you are to this prototype set. And
So you're still
do you
dealing with
identify?
probability, but it's a more
Exactly.
guided
Yeah.
Exactly.
training. Yeah,
Absolutely. Yeah.
interesting. So you're sort of trying to replicate all of it's thinking back to the books about breast cancer diagnosis, breast cancer pathology. You're trying to sort of replicate all of those scenarios and give variations around each one so that it can start to build a predictive analysis of every
Analysis.
chapter of that
Yeah.
book,
Exactly.
or the two
And the
that you're
only thing,
focused on.
yeah, and the only thing unknown that I try to address is the importance of these features. So, like, I know there is a gas stove, I know there is a microwave, I know this, I know that, but what I want to learn from a machine learning perspective is what is the importance of the refrigerator.
Right.
I shouldn't tell that. Then it'll be a rule based model. It won't be a machine learning.
Right.
I want the AI to tell me that, okay, I see a refrigerator there and I see a microwave there. And since I see it together, I'm giving it a very high score,
Right.
important score to detect it as a kitchen. So, and that's when you have an explainable framework, and that's where the AI comes in. And for that, you feed in like a lot of images and a lot of variations and come up with this important score.
How, on the data side, my understanding of how all this works is you need a lot of data, a lot of images, a lot of training sets. How did you kind of I guess one, is that true in this case? Like, did you need, I don't know, thousands and thousands and thousands, hundreds of thousands of scans? And if so, kind of how did you approach getting all those and
Yeah.
all the work there?
Yeah, so I think one thing is, especially in the field of pathology, getting annotated data sets is it's a bottleneck.
Yeah.
You do not have access to so many images because you need to go through regulations, get permissions and all that, and plus get annotations for that. And again, we did not work with the entire whole slide image. We did a patch-based classification. What that means is we broke down this entire gigapixel image into multiple small patches of like 2K by 2K size. So again, we did not have access to a lot of data. And that is why for this approach, which is a prototype based approach, does not require a lot of data. And it's called a few shot learning, which is like, okay, given less number of images that you have, how much can you learn from those images? Like, okay, to give you an example, say there were only 4 variations of how a kitchen would look like, right? I call it a kitchen only if I have 4 different kitchen types, and that's about it. Like, that is my prototype set. So you do not need thousands of kitchen images. You just need 4 images for the kitchen type, and try to compare your training data you have and try to understand as much from the prototype set that you have. So,
And is that because it's
uh,
a guided training, partially, that it's not trying to
absolutely.
make, yeah, because it wouldn't be
Absolutely.
enough to draw its own conclusions from 4 different
Yeah.
kitchens, but you're saying, okay, this
Exactly,
is part
exactly,
of it.
exactly. Yeah. So to put it in a different context, just imagine this: if in the entire world there was only one way that a kitchen would look like, you call it a kitchen only if there is like a refrigerator, microwave, gas stove, and if there's anything different, you don't call it a kitchen. Then it'll be quite easy, right? You go look out for these things. There won't be any disagreement between anybody because this is how
You
we would
wouldn't
call
need the
it. So,
AI. Yeah.
Yeah.
it'd be-
exactly. Well, we might need AI to detect these things, but it'll be a different sort of AI to detect these features. So we try to form a prototype set. Again, not perfect. This was just as a starting step, as an approach that you can take when you do not have access to a lot of data, and you could form
cool.
this small prototype set and then go from there. So
Very cool.
It's incredible stuff that you guys are working on, and I can imagine that's going to just blow open the field of pathology in terms of how much more accurate it can become. Where else do you see AI going in medicine beyond just pathology? What else? What's the future of this?
Yeah. So we are seeing AI being involved in drug discovery, wherein you need to parse out several different permutations and combinations to identify that, one drug that could solve a disease. Having like statistical models is good, but I think with the advent of AI and supercomputer capabilities and all that, you could simulate so many more combinations and try to understand how do we get a particular drug working. And I think AI is being used there. AI is being used to analyze electronic health records and in a much more faster pace and try to suggest personalized treatment. I think AI is coming in at almost every branch of healthcare or medicine. But from a developer perspective, I think you need to focus on problem first and AI next. Do not chase AI as a solution, but focus on what the problem is and if you actually need AI for that solution, or where would you need AI? Because that now makes you think, okay, where exactly would I need AI to help my efficiency or help in what I want to do? And explainable AI is quite a hot topic right now, but there might be some domains where explainability might not be required, like probably for drug discovery. So if your problem is just to find a needle from a haystack, you need to find that like that one combination of molecules which will act as a drug, which is like finding like that needle in a haystack. If that's your problem, you're chasing just to find that. You do not care if it's explainable or anything of that sort. You want to get to that state
Right.
as fast as possible and try to experiment. So you need not spend resources and time to induce explainability into that. They need to be right only once, and then you have like $1 billion drug out there.
Yeah.
So you need to like sit down and try to identify the problem, and yeah, I think that will be the right direction. So.
Very cool.
Are we seeing, in terms of drug discovery right now, is that something that where we've actually seen success from AI, or are you even aware of it? If it is that something that's public?
Yes, I think there are so many studies that happens in national labs, and I was involved as a research assistant at Oak Ridge National Lab back during my master's. This was 2016-17, and there has been a lot of progress when it comes to using AI to simulate these proteins and try to identify like drug targets and all that. There is some phenomenal work happening in national labs and elsewhere in this field.
And like you said, that would be more black box. They don't care how they get there. They just care if.
Yeah, again, with a pinch of salt. So in some cases, it might so happen that they want to understand how a model came to this conclusion, because now based on that, they want to maybe build drugs for similar diseases, right?
Nice.
There, some sort of explainability might be required. Again, it's what problem you're trying to chase. But if there is a disease and all you care about is, okay, getting to that solution as quick as possible, then you just run your experiments on these huge data sets. So.
Yeah. Well, I like how you said it, the problem first, AI second approach, that let's figure out what it is that we're trying to solve, figure out how we need to solve it, and then whether AI makes sense.
Exactly.
Yeah, that makes a ton of sense to go that way. Akash, this is incredible stuff, and it's completely blown my mind. I hope the audience is listening to this and really seeing that the future of AI is way beyond what we're sort of seeing in the media. This is not something that you typically hear about these days, but it's just incredible what you guys are doing over there, and the potential that this has to really improve people's lives is just marvelous. It's wonderful that you're working on that.
Yeah.
Thank you, Sean.
Yeah, so thank you for joining us. And yeah, this was really a pleasure. Everyone, thanks for listening, and always keep learning. Did you learn something just now? Get the full episode of Ways We Learn wherever you get your podcasts. And while you're there, we'd love to get your rating or review.